Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is maximum maximal network rank. So there is an infrastructure of n cities with some nodes connected connecting these cities. Each node is represented by this uh, 1D array A, comma B, which indicates there is a bidirectional node between the cities AI and BI. So the network rank of two cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. So for example, let's take this example. So let's say we will consider the network rank of pair of cities 1, comma 0. So how many number of cities are connected to this 0 directly? This and this. And how many cities are connected to one directly? This, this, and this. So there are three cities connected to one directly and two cities connected to 0 directly. Also, it is to be noted that these two connections are the same connection, so it will be counted only once. So the total number of connections will be 1, 2, 3, and this these two counted as 1, so 4. As you can see, the output is also 4, and the explanation is here. You can check it out. So let's move further with the problem statement. So what we have to do is we have to return the maximum network rank possible in this connection of cities, or say network of cities, for of the different cities. So given an integer n and the array roads, return the maximal network rank of the entire infrastructure. So the city numbers will be from 0 to n minus 1. As you can see, these are the constants. So the number of road road connections in this roads array will be n, and roads length is given of order n square, and also length of each 1D array in this 2D array roads is of length 2, and it is mentioned that there is no self loop, which means a city is not connected to itself. There is no edge connecting a city to itself. So these two values will be pairwise distinct. So I hope you are able to understand all the constraints, and each pair of cities has at most one road connecting them. So there is at most one pair connecting. It means that there is no city that is not connected. Something like this. Such situation does not exist. There is a path from every city to every other city. The same thing mentioned here. Each pair of cities has at most one road connecting them. So based upon n cities, and here is the number, and your cities will be in range 0 to n minus 1. So if there are n cities, how many pairs of cities can be formed? They will be of order n square, which is nothing but what is the order of n? N's order is 10 raised to power 2, and 10 raised to power 2 raised to power 2 will be 10 raised to power 4. So the number of pairs of cities will be order 10 raised to power 4. So let's consider a brute force way to solve the problem. Let me quickly change the color. So in brute force way, we will be generating all the city pairs. And these city pairs, number of city pairs will be of order n square, and it will be 10 raised to power 4. So 10 raised to power 4 is lesser than 10 raised to power 8. These are the number of operations allowed in 1 second. So those of you who are new to this concept, if the number of operations of your program does not exceed or become equal to 10 raised to power 8 operations, which are the number of operations allowed in 1 second, then your solution will be accepted. Also, I will be providing a link of an article describing how the time complexity of accepted solution varies according to input size. You can explore this article and then you will be able to understand this concept of 10 raised to power 8 operations limit in a much clearer way. So let's move back to the approach. So since our approach is will get accepted, we will simply generate the number of city pairs, all the possible city pairs, excluding pair of city with itself. So, and then once we are done with generating these city pairs, then we, for each pair, we will count, we will calculate its rank. And among all these ranks, we will be returning the maximum rank. So this is what we will be doing. We will be greedily returning the maximum rank. So let's move to the coding part and see how this will be implemented. Let me quickly zoom out so that larger portion of code will be visible. So connection score is nothing but how many cities are directly connected to a particular city. And this graph represents the connection between the cities to represent connection between cities. For each pair of cities given in this nodes, we will be increasing its connection score. For each pair of cities in roads array, we will be increasing connection score for both of the cities. Since okay, it's understood that the road is bi-directional, so it connection score will be increased for both of the cities. So this is for showing the representation bi-directional edge between for showing or say representing the bi-directional edge or say what it's called here or say bi-directional road between two cities. So once we are done with forming these two, this is the final structure that we will be storing our ranks in. This is the array or say vector in which the calculated ranks for each pair of cities will be stored. Also, it is to be noted that for two cities to be considered a pair, there is a need not to be a direct connection between them. For example, you can consider 0, 2 for a pair of cities. You can see that they are not connected directly, but you can consider them for a pair. So we will be calculating the rank of the each pair of cities. And then we will be returning maximum of them. So you can apply sorting or you can directly search ranks array linearly. That's up to you. I have applied sorting here and we will return the, I have sorted in descending order. And you will return the maximum rank possible. So it. Uh, this is how you will be solving the problem. If you are still having any doubts, please feel free to ask them in the comment section. Thank you for watching. Thanks.